Today in pre-calc, we were talking about the fact that each trigonometric function has a reciprocal function, meaning, for instance, that the cosine of theta is the reciprocal of something called the secant of theta, okay? And vice versa. The secant is the reciprocal of the cosine. And this is just a fancy way of saying 1 divided by something, that's the same thing as saying the reciprocal. Then we have the sine, which is the reciprocal of the cosecant, and the cosecant is the reciprocal of the sine. And then we have the tangent, which is the reciprocal of the cotangent, and the cotangent reciprocal of the tangent. Now, in terms of remembering which two go together, the way I kind of, in the past, have thought about it is tan and cotan's kind of easy. You know, one's the co of the other. So tan and cotangent definitely go together. As far as secant and cosecant and sine and cosine, in terms of which ones are reciprocals of each other, to me, I just think of it as each pair that goes together has one that has co. So cosecant would not go with cosine would not go with cosecant because that's two cos. So cosine goes with plain secant, and sine, which does not have a co, goes with cosecant, which has a co. Okay, so that is short for C-O-S-E-C-A-N-T. This is S-E-C-A-N-T. So that's how I kind of think that they could be remembered. I mean, really whatever works for you, works for you. The other thing you need to know, though, is that the tangent is the sine over the cosine. Okay, so if we know these things, then we can figure out anything we want to about a unit circle angle just from knowing the coordinates, because the coordinates, remember, are cosine and sine. So if I know the coordinates, then I know the cosine, I know the sine. I can take this, flip it upside down, and that gives me the secant. Take this, flip it upside down, that gives me the cosecant. I can take the sine and put it over the cosine, and that gives me the tangent. I can take the cosine and put it over the sine, or flip this upside down, and that gives me the cotangent. Another way of thinking of it in terms of how does it fit with the coordinates is this, that on the unit circle, we know that the cosine is x, and the sine is y for every point on the unit circle. So then the secant is 1 over x. The cosecant is 1 over y. The tan, since it's sine on top of cosine, is y over x. And the cotan is x over y. And I kind of wrote these funny so that the ones that go together work like this. So these two are reciprocal functions, these two are reciprocal functions, and these two are reciprocal functions. Okay, so if I know the coordinates, then I'm going to be able to find out any of the 6 trigonometric functions for that angle, whether it's given in degrees or radians or what have you. So let's say, for instance, secant of 315. I just want to talk you through the process I go through in my head when I'm trying to figure this out. First thing is, secant goes with what? Well, secant's the reciprocal of the cosine. So this is going to be the reciprocal of the cosine of 315. So then the next thing I think about is, what is the ordered pair at 315 degrees? In other words, what is the point at 315 degrees? Well, the point there is square root of 2 over 2, negative square root of 2 over 2. Well, I'm looking for the reciprocal of the cosine. Here's the cosine. So if I take this, which is the cosine, and then flip it over, that's going to give me the secant of 315 degrees. So here's the cosine, here's the secant. Only one problem, we can't leave it in that form. We can't leave a radical in the denominator. So I multiply by square root of 2 over 2, or excuse me, square root of 2 over square root of 2. And that gives me 2 root 2 all over 2, or just square root of 2. And that's my answer. Okay, let's do another one. How about the cosecant of 2 pi over 3? All right, the first thing I think of is, what does the cosecant go with? Well, that's tied to the sine. So this is really saying, what's the reciprocal of the sine of 2 pi over 3? So now I have to think about, where is 2 pi over 3 in terms of coordinates? 2 pi over 3 is at negative 1/2 positive square root of 3 over 2. We're looking for the sine, so that's this. There's the sine. If I flip it over, I get 2 over square root of 3. That's my cosecant. So that's my answer, but it's not in the right form yet, so I have to go ahead and write it in the right form. So I multiply by square root of 3 over square root of 3, and that gets me 2 root 3 on top and just plain 3 on the bottom, and that is my answer. Okay, let's try one more. How about the cotan of, well, let's see what I want to do. Well, let's do a quick one. Cotan of pi. Well, cotan of pi is going to be the reciprocal of the tan of pi. Okay, so let's think about the coordinates at pi. The coordinates at pi are negative 1, 0. Tan is y over x, or sine over cosine, so that's 0 over negative 1. So the tan here is 0. So the cotan is 1 over 0, which is undefined. So I would say undefined. So for tan and cotan, you can get undefined as your answer, because you can have a 0 in the denominator. All right, how about just plain tan of, let's do a negative one. How about tan of negative 5 pi over 4? Well, if you want to, you could change that to a positive angle first. You could say, let's add 2 pi to that, which means adding 8 pi over 4, which means positive 3 pi over 4. Or you could count around that way and figure out where this is. Okay, so tan of 3 pi over 4. The coordinates at 3 pi over 4 are negative root 2 over 2, positive root 2 over 2. All right, so the tan is the second coordinate over the first, the y over the x, or the sine over the cosine. When you are dividing fractions and they have the same denominator, those denominators cancel. Besides which, for tan, we're dividing two numbers that are exactly the same thing. So we have this, which is basically just negative 1. It's helpful to realize that, I printed one of these out to show you, and I decided not to use it. But here's a good place to use it. The tan, since the tan is equal to sine over cosine, anytime the sine and the cosine are the same number, it's going to be some variation of the number 1. In other words, 1 or negative 1, depending on the signs of the number. The signs, positive, negative signs. So in other words, basically at the 45-degree reference angles. That's when you have tangents that are either positive 1 here, because this is something over itself, positive 1 here, or negative 1, which happens here and here. In other words, if I put square root of 2 over 2 on top of square root of 2 over 2, that just gives me positive 1. Okay, same thing down here. They're both negative, so the tan is going to be 1. Up here, I'm putting square root of 2 over square root of 2 over 2, but one of them's negative. A positive divided by a negative is a negative. Down here, it's a negative divided by positive, so that's a negative. All right, so let me give you, I made a couple more examples of these, just sort of thinking through the process that you might want to look at and think through and see how it works and how it fits with what you already know about sine and cosine on the unit circle.